Hi, everyone. We are going to look at the concept of rate of change versus slope. And it's really helpful to see it in terms of a table. It can be helpful to see it in terms of a graph too, because you'll see a perfectly straight line versus like sections of a line that are straight, that are sort of bobbing up and down. But we are going to look at rate of change versus slope because you are going to be practicing finding slope given tables, and the tables are sometimes more real life tables versus ones that are constructed by the book. So rate of change versus slope. We're going to first look at this. We have the cost of stamps over time, and these cost of stamps has increased over time. And when we look at these increases, they're not necessarily a steady rate of change between 1985 to 2004, but there was a steady rate of change in between some of these. So we can look at the rate of change in terms of like from one year to another year and look at those particular differences. So rate of change is going to have us look at our dependent variables in comparison to our independent variables. Our independent variable is oftentimes time, which we've already talked about this quite a bit when we were doing functions, versus our dependent variable. If we look at our cost of the stamps that is related to time, it's gone up by 3 cents in 3 years. It's gone up by 0 cents over 2 years. And we are just going to look at these changes over time. So it's increased by 4 cents in 1 year, and then increased by 8 cents in 13 years. And so our rate of change, as we can see in this situation, is not steady. 3 over 3, and comparing our independent or dependent variable versus our independent variable, 3 over 3 in between 1985 and 1989. 1988 is not the same as 0 over 2, or that is not the same as 4 over 1. Let's see if you can see that. Yeah, you can still see it. And that is also not the same as 8 over 13. However, we can still see that there is change and variation between each one of these, and that's fine. Essentially, we're looking at the rate of change between these intervals. That is different than slope. So slope in terms of a linear equation, we are looking at the rate of change that is happening with this table, and we're going to assume that it should be constant because we should have a linear relationship, meaning as we increase here, we might see a decrease here, and it's steady. So a slope is implying that there's some steadiness to this. Rate of change is not necessarily implying that there's steadiness to anything. We're just looking at how things change over time. Whereas if I look at slope, I should be assuming that there's some steadiness. So what we will see in terms of a table is, again, I'm going to be looking at my change in my dependent variables. So in this case, when we're looking at y's versus x's, our y's are always our dependent variable. X is always our independent variable. We're going to look at our independent versus dependent variable, and we're going to see how they change over time. And ideally, if this is a true slope and if this is a true linear relationship, we will see a steady increase each time. So 3 to 0, I'm subtracting by 3, 0 to negative 3, subtracting by 3, negative 3 to negative 6, subtracting by 3. Notice I'm focusing on my y's first because slope is looking at our dependent variable compared to our independent variable every single time. Negative 2 to 0, we're increasing by 2, 0 to 2, increasing by 2, 2 to 4, increasing by 2. So if I wanted to look at this now, I could say my change in my y values compared to my change in my x values. So that's a way that we can look at slope, which we talked about in the last video. My change in my y values is a steady decrease of negative 3. My change in my x values is an increase of 2. So my slope is negative 3 over 2. I could also say that's negative 1.5, but again, I want you to always keep it in rise over run form if you're going to keep it as a fraction, or if you're not going to turn it into a whole number or an integer, which we cannot do in this case. So please just embrace the fraction of the negative 3 over 2 because it will make your life easier when it comes to graphing. Cool? Cool. So here's how we're dealing with rate of change versus slope in tables. So looking at a consistent change in our x values versus our y values. One more video after this, we are going to look at just plain numbers and just plain points and finding the slope given the slope formula. And then after that, you can work on the must-do practice problems.